There we go. I think it's working. Yeah, it's working. Hello, I'm Centauri, and today I'm just going to be going over the basics of making AI in Udon Sharp. So we'll be learning things like, so first we'll be making just a small, simple AI that will be chasing the player around. Then we'll be making a dog and assigning Fiona. I swear I didn't know about your dog world until after, but you'll notice there's a lot of similarities. I know. So we'll be learning how to do things like having the AI wander around, chase the player, guard things, play fetch. And then at the end, we'll be taking that final AI that we made local and syncing it across the network for everyone, including join sync. Okay, and there we go. Okay, so as far as who am I to tell you about your AI? So I've been working inside and outside of VRChat for multiple years now, making worlds, and most of them have had AI in some way or another. So there's like my escort map, which was a shooter against AI, and then there's like Noir, which had a bunch of AIs in it. And what you'll need is SDK3, obviously, Udon Sharp, and then after the talk, I'll be releasing a Unity package onto the database for something called Simple AI, which will have a bunch of prefabs and stuff that you'll want and be able to use, and also an object for syncing.
Nice.
And hang on. No, that's right. Okay, basic terms to remember. The two main things we'll want to know for this will be the Nav Mesh, pathfinding, and the Nav Mesh agent. Because those are the three big things we're doing. So the Nav Mesh is something that you'll be baking onto your world, which is a 2D representation of where the AI can and cannot go. Pathfinding is the point between the AI and where its destination, that you'll be controlling that to figure out how the AI gets where it needs to go. And then the agent, think of that as like the heart of our AI. The controller is the brain, the actual Nav Mesh agent is the heart. The heart will be what will allow us to do things such as obstacle avoidance and just setting different speeds, acceleration, stuff like that. And I actually just talked about this before, but we'll be creating simple AI, and we'll be doing different states, how to sync it using UNO. And then I won't be teaching you what to do with the variables once you get into an animator, but I'll be showing you just how to get a few of the different parts of the AI into an animator as parameters. And this is what you won't learn. You will not learn how to make stuff in SDK2. You won't be doing it, we won't be using Udon graph or Scion triggers, and I won't be teaching more advanced AI such as swarms of different or RTS style thing. I won't be doing any of that. And if you do want to learn those things, I am free to teach you how to do them, because I do know how to do them. It's just I'm just teaching the basics. And we'll be starting with the Nav Mesh. You need to know how to do this to be able to do literally anything else. All right, what is a Nav Mesh? A Nav Mesh is something that Unity handles that allows you to take the geometry of your world and make a 2D representation of it that the AI can move around on. So when making a Nav Mesh agent in an AI, you don't want to just use the generic geometry of your world, because that makes a lot of the complications super, it makes the calculation super complicated and stuff, and it's possible, but within the constraints of Udon, you usually don't want to do it. And yeah, and then there's a little picture of an example of what one looked like. And they're important because just all the things I just said there. You can set different limits on where AIs can go. So like, let's say you don't want an AI to be on like a random roof or something. You just don't have that be a Nav Mesh agent, because without it, you'd have to do a bunch of actual calculations like, oh, hey, you don't want to go past this point, and you'd have to do a bunch of stuff for that. But with a Nav Mesh, you can just have it handle all that for you. All right, next we'll be going through Nav Mesh areas. Nav Mesh areas, Unity allows 32 of them. They're very similar to layers. And they have different things. So there's like cost, things like that. And you can assign different parts of your world to different areas, and you can make areas have different AIs to control them, because Nav Mesh agents have masks that you can use. pathfinding cost. This is a more complicated way of doing it, which allows you to give different areas of the map different, like, let's say you have, like, for the picture right there, the area in between the two sets of the stairs and the ramp has a higher cost than everything around it. So it will first try to find another path, and if it can't, then it'll go through that. Because Nav Mesh agents always try to find the lowest cost path to its destination. And now for the VRChat specific part of it. Currently, when uploading a build on the VRChat, cost is not uploaded with the build. So you have to assign it at runtime. This is super easy to do, and if you don't want to do it yourself, there's also a prefab in SimpleAI that does it for you. But you basically on start, you just have to go through all of them and manually assign the cost that you would set in the editor. It's not that hard to set up, but it's something that we needed to do. And here's a real-world example of cost. So let's say right here you have the player and you have the actual AI. Where's the pointer? Here's the pointer. Okay. So you're here and the AI is there. The AI is targeting the player. You want the AI to reach the player, but there is a river in the way. The river itself, you set the area of the river to have a cost of 4, and you have the area of the bridge as a cost of 1. First, it will try to go directly there, and it will detect that the cost is super high. So then it will do it again, and it will see that there's this bridge over here that has a cost of 1. So then it will go around over to the bridge and across. However, there is exceptions to this. Let's say that the player and the AI are like way over in the distance, and the bridge is super far away. The cost is just a multiplier of that specific area. So think of it as the normal distance of that area multiplied by the cost. So if the cost to go straight across is still less than, even with the multiplier, than it is to go across the bridge, then it'll go straight across. All right, Nav Mesh Baking. With the Nav Mesh, you have to bake it in the editor. It's technically possible to generate during runtime, but it's not recommended. And yeah, hang on. So there's different variables with it. So your basics are the radius, height, slope, and max height. The radius is just the size of the AI, because AI agents always have they're a cylinder. And the radius will be the distance from the center. So when generating a nav mesh, it will take the edge of the nav mesh itself will be the center, but it will always be within the distance of the radius, so that the AI won't clip through things. Height is the same thing, but for height, if there's something in the way and it's underneath the height of the agent, no nav mesh will be generated. Slope is like a ramp. If the slope is above a certain angle, nothing will generate. And then step height is something for like stairs. So if it's above the angle, but it's within the step height, it will still generate a nav mesh between them. And then for the more advanced stuff, you just don't want to mess with these, but you can change the voxel size, because a generated nav mesh is a mesh, so you can make it denser or less dense. Minimum region area, that would be like, let's say you have a teeny little pillar, you don't really care to have a nav mesh on it, you can not have height mesh. Height mesh, as far as I'm aware, that is completely outdated and not used anymore, so we don't really need to care about that. And now for generated off-mesh links. This is something that is more advanced, but it is good to have. You can have drop height and jump distance. Drop height is like, let's say you have an AI on top of a wall and you want to have them be able to jump down onto the ground. You would use drop height to make it so that you can automatically generate off-mesh links. Because setting them up manually is possible. It is easy. It's just tedious. So this allows you to do it for you. And jump distance is just the maximum distance between two otherwise separated nav meshes that you can have it automatically generate a link between for the AI to cross. All right, so now we're going to be talking about the nav mesh agent itself, the heart of our AI. So the nav mesh agent script is something that's built into Unity that we can just do whatever with, and it just allows us to easily connect to our generated nav mesh. And it has a bunch of different area like settings and stuff that you can change, which I'll go into each of them now. So we'll be starting with steering. For the steering, there is these 5 different variables. Speed, which is the maximum speed that the AI can go at any point. Angular speed, which is the maximum speed that it can rotate. Acceleration, which is the maximum like just velocity that it can accelerate from stop to wherever it's going. And that is the units per second squared is the function for that. Stopping distance will be the distance from its destination that will stop, which this is good for things such as AI that you're wanting to follow the player. You don't want them to clip into the player by following directly to their position, so you can have a stopping distance of like 2, which makes them stop right before the player. And then lastly, there is auto braking. Auto braking means that the AI will dynamically slow down before it reaches a point. It's good to have this if you want to go to a specific point. However, if you're doing something such as patrolling, you don't really want it to stop at every single waypoint in between. So you can turn off auto braking, and it will just automatically go through the point and continue on to its next one. That would be something you'd have to have some scripting back in for as well. And then there is obstacle avoidance, which this is specifically for dynamic objects. Because the Nav Mesh Baking handles all static objects in geometry that will allow you to just move around static objects. However, there is also dynamic objects with like things like the obstacle script, and this also handles for agents moving around each other. And these are the exact same settings right here as on the baked one. Usually you want to keep them the same as your baked nav mesh, or else it'd be a little weird. And then quality settings, I found it's usually fine to keep it on high, but the more AIs you have, the more CPU time, and if your CPU time is too high, you can turn down the quality. And if quality is set to none, then it just won't do obstacle avoidance around dynamic objects. And priority, this is the last one. Priority allows it to like let's say you have 2 Nav Mesh agents, one with a priority of 25, another with priority of 50. The one with 25 will go around the one with 50 as it's moving, because it just makes some AIs be more important than others. And then lastly, pathfinding. Auto traverse off-mesh links, that means they'll just automatically use the generated off-mesh links. You'd only really want to disable that if you're using custom animations or something to go between them. Auto repath, that allows you to, let's say that you have a destination that's all outside of the actual nav mesh. It will generate a partial path to the furthest point it can go. Then if you have that enabled, it will attempt to generate it again to try to keep on getting to that point. However, if you don't, it will reach that partial path and it will just stay there until you attempt to generate a new destination. And then lastly, area mask, that just connects back to our area system to specify which areas out of the 32 that you want it to be able to use. And let's go to the next one. All right. Nav Mesh obstacles. This is another script that Unity has. This is something you'd want to assign this to all of your dynamic objects that are not agents. So like let's say you have a crate or a barrel or something, and you want the AI to try to move around it. That would be what the Nav Mesh obstacle is for. And the shapes, it can be in a box or a capsule. And then for the more advanced stuff, there's something called carve. Carve allows the obstacle to actually cut into the static nav mesh and prevents it from going in it by completely removing the ability, like temporarily removing that section of the nav mesh dynamically. And that is good for big obstacles such as like let's say you have a room with a big wall that's slowly moving across it. You would want to use carve, or maybe a tank moving through a row of infantry. And then you want to disable it if you have a constantly moving object, like a ball moving around. You'd want to disable it for that. Move threshold would be the minimum distance from its resting position before it will no longer carve. Time to stationary is the time it waits once it's no longer moving before it sets itself to stationary. And carve only stationary means that it will just only carve when it's stationary, and if it's off, it will always carve. And if it's always carving, there is a performance hit to that. So you only want to do it if you absolutely need to. However, if you're not carving into to the nav mesh, having a super cluttered scene can cause the AI to get super confused and get stuck. So you always want to keep that in mind. All right, now we're going to be making our first AI. And this is a very dapper boy. So let's go. Well, what we'll need. First, you'll want to have your geometry, of course, and your baked nav mesh. You'll want to have just an empty game object with a nav mesh agent and a new U# script. And there you go. Come on. There we go. All right. Now we'll want to set up our variables. You'll want to make it so you're using UniEngine.ai, or else you won't be able to reference back to your nav mesh agent or any of your nav mesh paths or anything. And we'll want to set up some variables. You'll need to reference back to your agent, and then since we'll be targeting our player for this first AI, we'll just have a target player VRC API. And then in start, we'll just assign our variables. All right, now we're gonna make it target the player. This is super simple, and all we'll have to do is create an update loop, and then nav mesh agents have a function built into them called setDestination, and that you feed in a vector3 value, and then you're good to go. So, and right now we're having it have the target player's root position be set as a destination. So then every update, it will just set the destination. However, if you have a lot of AI constantly calculating new paths every update, it can get performance intensive. So usually, if you have a lot of them, you want to set on some sort of timer system or make it so it dynamically recalculates them based on where it is at the time. But for now, with a super small, simple AI, we can just have it be on update. All right, and then the last thing you want to do is you can just go back into your nav mesh script and just modify your settings. That's completely up to you. It's really just like if you want to change the speed or change the level of obstacle avoidance and stuff. And that's something that you just want to mess around and tune yourself. And that's it. And now you'll have the basic AI. Now for the fun thing. Doggo time! We're gonna make ourselves a doggo. And this will be local. We're not gonna sync it until after we finish making the local version. And to start, we will make it wander, because why not? All right. Starters, we want to do the exact same thing we did before, and we'll be using our AI we just made as a reference for every AI after it, by the way. So they'll keep on building on each other. So to start, we'll be adding these variables. We'll need our max wander distance, which will be the distance that it will go from its current position to a new position. The larger the distance, the more performance intensive that it is. So usually you want to keep it pretty low. And then the wander idle time, that will be the amount of time it will wait at its new position before it calculates another one. And then we'll just have a few internal checks that we'll need. All right, now to modify your existing code. We will be assigning new stuff and a few new things in start. We will be removing the destination from our update because we'll be redoing that with a bunch more stuff later. And then we'll be creating a new function. When you have a bunch of different things all setting the AI, it's better to keep it all in one place and then just having a set function with a vector3 that you can feed into it. And then inside of that, then we'll be having it set the destination. And that's just to keep the code clean. All right. Next, we need to calculate the position of the nav mesh. And this is to do this, we will first want to create our own function for it. Usually best to keep it all in separate functions because then it keeps it clean. And for this, we will be using two things. We'll be using something called inside unit sphere and navmesh.samplePosition. The inside unit sphere will be used to calculate a point in 3D space around our AI. So, because what it does is it just takes a sphere of a certain size, which is by default is 1, so we need to feed in our max distance here. And then you'll just add your current AI position to it to make it be around the AI. And that will give us a random 3D point around our AI within a certain distance. And then next, we'll want to sample our position. And what sample position does is it takes our 3D point in space, which is right here, and then it takes a distance from that space, which will just be using the same thing that we fed before. And this is where it really can get intensive, because what happens is sample position first goes up and down within the distance. If it can't detect anything within that distance, it will then start going out to the distance. And if you have to do that, if it goes out, that is where it can get really, really performance intensive. So you usually want to keep that relatively low. And then lastly, you'll have your areas. For this, we're just having it set to all areas, but usually you want to feed in your specific agent's area mask so that it doesn't find a position on an area that you can't actually go to. And then it just outs it to this nav mesh hit, which is just the point on the nav mesh where it finds, and then you can return that position of that. And then now, there you go, now you have that. And then we'll need to finalize it all in an update loop. So first, we'll want to have a timer, which this could also be as a custom event delay time, but I forgot about that when I made this timer. And then it will, for this, we'll have it so when it's idle, it will wait at the idle position for the set amount of time. And then once the time is over, then it will reset variables and then start wandering, which the start wandering function is just something we quickly create to be able to call anywhere that's just like, oh, hey, you want it to wander now? Yeah, there you go. Now you can have it wander. And then the other thing is that we need to make sure to detect when it reaches this new position. And for this, we'll just have check the remaining distance. And if the remaining distance is less than 1 and it has already set a position, then it will reset itself and then it will begin its new thing. Because the set position is how you make it so this code doesn't run over and over and over. All right. And that's it. With that, your AI will now always just move around randomly. It will just, every time it reaches a new position, it will find a new position within your set distance and it'll just go around. All right, next we're going to re-implement what we did before. And this is pretty simple to do. What we'll want to do is first, we'll want to add a variable called current state. We'll just have it as an int, because if it's an int, we could just keep on adding it, and every number above will just be a new state. And then we're in our update loop, we'll want to put our existing code into a switch statement. A switch statement will allow us to take our int variable and then have specific cases for each state, and it's one of the easiest ways to do it. And then we'll take our code, just copy it in here, and then what we can do in case 1 is we can just have our set AI destination, which is the function we set before, and then we just have that set to our target player's root position. And now, when you set that to 1, it will follow the player, and if you set it to 0, it will wander around. However, right now, the player has no control over it. So what we can do now is, on our AI itself, we can put a little sphere collider on it, which has an interact, and inside the interact, we can have it reference back to our main controller and just swap between the states for us. And that's it. Now with that, your AI can just swap between them. You just go up to it, click it, and it swaps between them. Next, we're going to do jumping. And for this is where we're going to talk a lot more about off-mesh links, because that's what we'll be using for the jumping itself. All right, off-mesh links. Off-mesh links allow you to just get between different areas of a nav mesh that wouldn't normally be connected. So like on this, you can see that it can jump from here to this platform, to this platform, to this platform, this platform, and then over. And AIs would normally dynamically choose, since they're choosing the closest point, like let's say the player is right here, then it will choose to move here since that is the closest point on the nav mesh. And inside the nav mesh link, okay. So then for off mesh links, we have a start position, an end position, and which is just 2 transforms, and then you'll have a cost override, which means that, like, let's say there is a long path around and then there's a little hop that you can do. The cost override connects back to the costs for the area masks to allow you to make it so that jumping is more expensive or less expensive than going in a different area. Bidirectional, that just means that, hey, if you want to go from one side to the other and back, you can do that, or otherwise it's a one-way thing. Activated, just pauses activated state. Auto update positions is interesting. It kind of works. So what it's supposed to do is every time the transform moves, it will recalculate if the nav mesh exists or not, and that could allow you to just have moving off mesh links that could go all around. But I've noticed when testing that it only works like 3/4 of the time. I don't know why, but that's something I need to test more. And then navigation area, that is essentially just the area that you can set it to a specific area that you would have for the other nav mesh areas. And that's good. All right, how does that apply to our doggo? So specifically for our dog, we will want to be able, like when player, especially later on when we're playing fetch, you want the dog to be able to follow you to places around the map that it might not normally be able to get to. With off-mesh links, you can just have the dog go around in a specific area you can set for it, or you can have it jump through the air, do whatever. And that's it. Now our doggo can jump, because we don't really have to do anything on the dog side. All right, now we're going to add more states. This is just expanding on the basic states we have. There we go. Maybe, yeah, okay. All right, we'll be building off of the existing AI again, and to start, we'll want to modify our interact. Since we'll be having more than the 2 states, we'll want to have it cycle through them. So to do this, we'll want to have a maximum number of states, and usually you want to keep this to a specific set state. So like later on, we'll be doing fetching, we'll be doing guarding. Each of those have specific states for them, like guarding, guard, agitated, fetching, actually where it's actually fetching a stick where you wouldn't want it to be able to override it. And that is, you'd want to put those at the end, and you could add that to this. And so then they wouldn't go, it wouldn't cycle through those, it would cycle through the others. First, make it stand still or sit or whatever you want to do where it's not doing anything. And this is super simple. You literally just add a new case and you have it don't do anything. Because when it's not doing anything, it'll just go to its last known position and it'll just stay there. All right, next we'll be doing guarding. So guarding, we'll want to make it so that the AI will stay at a specific position, but if the AI moves past, if a player gets within a set radius, it will chase after the player for a certain amount of time before returning back to its previous position. To get started with this, we'll want to first create a detection sphere script that will be just the detection area. And then inside of that, we can just have it reference back to our controller. And then on a player enter trigger, we can just have it set its state to the 4, which in this case would be what we'll be adding as the guard agitated state. All right. Now there's a lot more we need to do. Now we'll be wanting to go back to our controller. And also for this, you can ignore all of these. Afterwards, I went back, and all of these can just be above the switch statement with set active equals 3. But right now they're in that for that code snippet. But we'll want to add a few variables. We'll want to add the actual trigger collider itself, the amount of time you want it to chase each player, the internal counter, because usually you don't want to override your existing counter that you already have, and then a vector 3 guard position, and so just where it will save for when it wants to guard. And then we'll add a few stuff to our start function to assign variables. And now inside of this, we have all of our existing ones, which is a 0 through 2, and then we'll want to add 2 more. We'll want to add guard, and we'll want to add guard agitated. Because when it's just in guard, it's not chasing any players, so you just want to have it be setting its position and then it just staying wherever it is. And then when it's guard agitated, it will stop setting its position, so therefore saving the last known position. And then it will start targeting the player and start a counter for the amount of time it will chase the player. And then once the timer's over, then it will just set the position back to guard and then set the state back to guard. And that's it. Now, whenever the player goes within a certain distance, the AI will chase it for a certain amount of time, and then when whatever you want to do for that, whether kill the player or whatever, then it will just go back to its last known position. All right, next we're going to be making something a bit more complicated. We're going to make our doggo play fetch. And for this, the first thing we want to do is create our fetchable pickup. This will be a stick or a ball or whatever you want it to be that the dog will go fetch. And then so for this, we'll just be creating a simple pickup script with a Udon behavior, rigid body, and in this case, a box collider. All right, now we need to set up our variables in the pickup itself. For this, we'll want to create all of this. Actually, no, this is the controller. Okay, so this will be on the pickup. This will be on the controller. I don't know why that's messed up, but it is. Okay. Wait, hang on. No, I'm right. No, I'm wrong. Okay, this is all in the pickup. So from the pickup, the first thing you want to do is you want to get all of these variables. We're going to need all of them. You need to reference back to your controller, and you want the grab point. So like in this case, the grab point will be in the dog's mouth. This will be what we're setting its position to while the dog is carrying it. Then we'll want to have an internal check for if it's being fetched, and then we'll also want a minimum distance from the player for it to go. Because like, let's say you throw the actual bone or stick or whatever, and it lands right at your feet because you're using index controllers or you're bad at throwing. And then this makes it so that it won't try to grab it right at your feet just to try to bring it back to you. And then we'll have a bunch of check functions for what it's doing at the time, and then we'll just be referencing our agent and our target player, which for this case will be the local player. And then we'll be assigning the variables on start. We'll also want to have our on pickup, on drop functions to control what it's doing based on what the player is doing. So right now with this, if it's on pickup, we want the AI to automatically go into, hey, I'm going to fetch this stick. And then it will also reset some variables. So like, let's say you throw it and then you want to pick it back up, you want to reset the existing variables. And then on drop, we'll set it to is being thrown to begin the checks for all the different things, like if it's far enough away, if it's valid, all that stuff. All right. Now we'll also want to create two more functions for picking up the pickup. So like this will be called when the dog actually gets to the pickup and wants to pick it up, and then resetting it, which will be calling if the actual throw is invalid. So like, let's say you're on the small nav mesh with the dog, you throw it way into the distance, it's not on the nav mesh, you can't even reach the pickup anymore. This will just make it so that the transform of the pickup itself will just be set to the player's right hand. And now we'll need to go back to the controller. For this, you can see right here, we'll be adding two more cases. We'll be adding the fetch wait, which is when the player has grabbed the pickup but not thrown it, and then 6, which is when the fetchable is actually out, so then it wants to set the destination to it. And the actual stuff in the controller, we're not going to be doing much there. Most of it's on the pickup itself. All right. Also I just realized in this, we'll also want to reference our fetchable. Every AI will only have one fetchable at the moment, at least. All right. Now we'll go back to our pickup script, and we need to add a update loop. There is a few things we need to check here. First, we need to check if it's being thrown at all, because if not, what's the point of doing anything? And then if it's being thrown, we have to first make sure that it has actually been thrown far enough from the player that it needs to go grab it. If that's true, then we will check if the rigid body itself is sleeping. This means that when you are throwing the pickup itself, the dog won't try chasing it, because when it's going through the air, we don't know if it's valid or not, and you don't want to chase after a thing and then find out it's valid, and then it'd be really weird to handle. So we usually want to wait until it has landed, and once it has landed, it will go into a sleep state, and then we can actually have the dog chase after it. And now, the last thing we need to do before we have the dog actually chase after it is we need to make sure that it is a valid path. To do this, we'll be using the super helpful function that's part of Nav Mesh Agents called Calculate Path. With Calculate Path, you can take a existing position from your agent, and then you can feed it in. So for this, we are taking our agent and we are feeding in the position of our actual fetchable object, and then we are returning it into a Nav Mesh path variable that we can use on our own later on. And once we do that, that's essentially like if you're setting destination, but without actually setting destination. Once we do that, we have something called a Nav Mesh path status. There's a few different things that it can return, but in this case, the only thing we care about is path complete. Because if it's complete, then the AI can reach it and we're good to go. Otherwise, we can just have the pickup reset and then have the dog go back to its following the player because they have a bone state. But if it is complete, then we will have it so it's no longer being thrown and it is being fetched. And then we will set the current state to 6, which in this case is to have it go track down the actual fetchable object. All right, now let's have the AI fetch it. For this, we have another really big if statement. And first, we need to check to make sure it's being fetched, and then this will be in the update loop. We'll have first it being checked if it's being fetched, and if it is, and we'll next need to check to make sure it's not being carried back. Because if we don't check that, when the AI reaches the fetchable and picks it up, it will detect that it is always really close to it, so it'll keep spamming this over and over and over. And next, we need to make sure it has stopped at its position, which this isn't entirely needed, but usually if you're getting the dog to pick it up, you want to make sure they're not running past it and picking it up as they go. And then lastly, you want to make sure that it is within a certain distance, or else it'll grab it immediately. So for this, we'll take the AI's position and the bone's position, or the fetchable position, and then we'll have it be less than or equal to the stopping distance plus 1. And we do the plus 1 to add a little bit of leeway. Because what can happen is the dog can get almost there, and then right when it gets there, something happens, and it can get in the way, or it's stopped too early or something. And that little bit of leeway is in most cases enough to detect that, hey, the dog's actually here, and let's pick it up, which will then call that function. All right, in that function, which was shown earlier, it sets is being carried back to true. So now that we have it's being carried back to true, and this is also in the update loop, we will first want to set the transform position rotation to our grab point so that the pickup actually goes into it. And then we'll want to set the current state back to 5, which means that it will just start chasing the player again. Even though we don't need a specific state for going back to the player, since all that state is tracking the player versus tracking the fetchable. And then inside of that, we'll now have another if statement to check when the actual AI is back at the player. So first we'll check to make sure that the agent has reached it with the velocity, magnitude, and the distance check, doing the same bit of leeway we need. And then this will make it so that it will go back to the player, and when it's within a certain distance of the player, it will drop it right here. Because if not, it will just keep chasing the player. So you can run around while it's carrying the bone back to you, and it will still not drop it because it's just constantly checking your current position. And then once it's there, it will reset the variables, set the current state to 1, and then the pickup will be a pickupable again. And earlier on, it did show that we did have it set to false, because when the dog is carrying the pickup, it breaks if the person tries picking it up halfway through. And that's it. Now, locally, the dog, if you throw a bone or a ball or a stick or whatever, and it goes past a certain distance, the dog will chase it down and then bring it back to you. All right. And last for the local AI is we just need to feed it into the animator. And this is super simple. All we have to do, the 3 states we'll be putting in is the AI state, the is jumping, and the velocity. And I'm not going to be showing you how to do the standard assets, the 2D the vector 2 thing. That's complicated. I haven't even properly figured that out yet. So we'll just feed in the velocity, which is just the magnitude, or the magnitude of the velocity itself. And then for this, we'll do right at the beginning of our update loop in our controller, we'll literally just set the variables. And for this, we could just put in the agent state. We can get the agent.velocity at magnitude, because that is a variable that we have access to. And then the agent we also have access to is on off mesh link for the is jumping check. And there we go. Our doggo is done. We have a Minecraft doggo. I would have had videos of it, but I ran out of time. Also in the Unity package, all of this stuff that I'm showing here will all have their own versions, and it will be a Minecraft doggo. All right, now we're gonna sync it. This will be interesting. Thankfully, I have Panda's big brain to lean off of on this. All right, ownership, This was explained in Panda's talk, but essentially the owner is who controls all of the sync variables and stuff on an object, and they serialize data across the network. Other people deserialize it on their end, and then you get that's all the variables we need. And honestly, for this, that's really all we need to know, because syncing in terms of syncing, there will be some ownership swaps and some synced variables, but beyond that, we won't really be doing that much. For player tracking, I'll be including this as part of the prefab. I'm not teaching you how to use an object pool, but I've modified a version of the simple object pool from the database, and that is what we'll be using to track each player. And for that, essentially, the only reason we do this is when we are setting positions and tracking different players, we are able to assume that everyone has access to an array of player APIs of every person, and it is the same for every player. That's all we need. And you don't even need to use this. As long as your object pool has the same stuff for everyone, you're good to go. And now we need to first set all our variables, and this will be in our controller. And also this will be all based off of the local fetch AI we just did. And for this, we will need to sync these 4 values, and you could probably do it in less, but this is the easiest way to do it. So we'll need to sync our state, our current destination, because for everyone else, we want to sync our destination, but we don't really care about what the destination is. We just need the destination itself. So we have that, and then we need our velocity and our off-mesh link. And these two is mainly just to feed it into the animator. If you want to do your own thing, you don't really need to feed those at all. And then on start, we'll be modifying our variable assignments, because a lot of these things we only need if we're not the master. So right now, because we're using object sync, which we'll also put an object sync script on the AI itself, for everyone except the master, you don't want the agent to manually update its rotation and position. And for this, you will just set them to, for the rotation, if you're not the master, you want it to be false. If you are the master, you want it to be true. And then for everyone, you want the update position to be false. And I just realized I'm missing a code snippet. There's a function that you want to have called onAnimatorMove, and inside that you want the master to have there's something called agent.nextPosition, and you want to set the transform position to that of the AI. And it's not down here. Crap. Okay. And then we'll just set all of the other variables. There we go. All right. Modifying our code. We have the same issue here that we had before. I already mentioned how to fix it. Just put the detection trigger up there before it, and then you're good to go. But for almost all of these, we want to do is owner checks, because if they're not the owner, then you don't care for them to run literally any of this code, because for them, they're just watching the player. So, because the owner is doing all of the code, everyone else is just watching the end result. So you go through all of these, and this is the case for all of them except for guard. For guard specifically, just to save some data going across the network, we can just have everyone locally set their guard position, because you can do the same thing, put the owner check there, and then have the guard position be a sync vector 3. But there's not really any need, because in most cases the position is almost exactly the same anyway, so it doesn't really matter. And besides that, all of this code can stay exactly the same. Mostly. I'll get to that in a moment. And then we'll also want to modify our set destination function, because what we need to do now is, but we had created that current destination vector 3, and we need that to be synced across the network for everyone. So we need since the owner of the object's the only one calling this anyways, we can just have set destination equals that, and then set destination current destination there. And then inside the update loop right at the beginning next to these, we will want to modify the inputs to have those synced variables. Current state can stay the same. These two need to be changed. And then it will now assign the destination for everyone except the owner, because everyone now has the current destination synced, but we still need to make sure everyone knows, hey, it's going to this position, hey, it's going to that position, so on and so forth. So then you can set the AI destination to that. And if they are the owner, then you can just set the synced variables to what is needed, which then we can feed back into the animator. All right. Next, we're going to sync the toggle. And for this, we want to have, for this, we just need to have our, whoever interacts with it to become the owner of it. Because you can broadcast to the master and have the master handle everything, but that means for whoever's actually playing with the dog, it won't sync up as well. So usually you want the person who's actually playing with the dog to be the owner of it, to make sure that everything's running locally. To do this, we'll modify this to have a bool to see if there's changes, because you don't, in this, you'll want to have that, but I'll explain in a moment. But first, you want to check if they're already the owner, because if they're already the owner, you don't really need to set the owner again. And if it is, then you could just call this custom function, and this function right here is literally just the code that was in the interact before, but as its own thing. And then what we'll want to do is, if they are not the owner, we want to set the owner of both the toggle and the actual AI itself. Because if you own one but not the other, you'll be trying to assign variables and it just won't work, because you're not the owner, so you only read them, you don't write them. And for this, we'll have that set owner, but we won't be changing state, because then we want to wait until ownership has been transferred. And once ownership has been transferred, you'll have this bool right here, because you're the only one locally having it active. And if you have that active, then you will change the state, because this will fires for everyone, but you only want it to run for yourself. So then you'll change state, and then it resets the bool itself. All right, next we're going to sync the guarding. For this, we will have to, this is very repetitive, but relatively, But for this, we'll want to add the player pool to be able to reference back to all of our players. And inside the player pool, we have a variable that is just an array of every player's API. We go through it, and then if you check that, if you have, depending on if you, the person entering it, is that player within the list of players, it will send a custom network event to the owner, and then this is going to be the tedious part. What I'm doing is I'm concatenating the existing, the target player and a int, and that makes it so that we can do this. We can have a custom function for every player that you can do whatever you want for, and even if you want to do things specific to a specific player, you can have that here. So you take this, this is an example, so like player 2, and then that's 1. You do that. For the example, I have 81. I swear I didn't write it manually. I did use code to make the code. But you just multiply it by the number of players, and then using that, this right here will call one of these. And then that will just set it will set the target player to the current player API. And that's why it needs to be the same for everyone, because if it's not the same for everyone, the player at the index 0 might not be the same for one person that it is for another person, and that could make there's being some desync between the different players. So like if you're guarding and you go in, and then the AI just starts randomly targeting someone else that's like 500 meters away. All right, that was all we had to do for that. Now that's synced. So now we need to sync our fetching. For this, we need to first modify our pickup. First, we want to take our isGrabbing bool and make it public, because we need to reference it back to in our main controller in a bit. We'll then want to go to our onPickup script and have them take the ownership of the agent itself when they pick up the bone. Because when they pick up the bone, they automatically take ownership of the bone itself, or fetchable, or whatever you want it to be. However, they don't take ownership of the agent, so we need to make sure that they have ownership of the agent, or else they can't assign variables to what we need it to be. And we'll set isGrabbing to true, all of that stuff, and then there's also check to see if they're already the owner, because if they are, they don't need to do anything. And that will just set them to the state. And then in here, in the update loop, all we have to do is we just have to add a owner check at the beginning, because no one except the owner of the actual script itself needs to do anything. And then all of this other stuff right here is almost entirely the same. All right, synced fetching continued. So now we need to continue on, and this is the one little bit that's different. And there's two different ways to do this. The way I'm doing here is a network event with the set pickupable right here, which will then make it so that everyone either can pick it up or can't pick it up. But you can also if you don't want to use a custom network event, you can also use a synced bool, and then have that be everyone locally run pickup.pickable equals that bool, and that would also work. But this is just a less network load than the other one, which is why I chose it, because the other one's continuous sync because there's object sync on this throwable object. And then right here, same thing right here. When the AI picks it up, it will set not pickable, and then when it drops it, it says it to pickable. All right, now we want to handle the last little thing right here, which is on ownership transferred, and then we also want to on drop set is grabbing to false. I forgot to show it before, so I had added it to this slide. For this, if we want to, only if it's grabbing, because this can fire if just someone leaves the instance, and we want to make sure the AI doesn't break when the owner of the actual dog itself leaves the instance, and we also want to kind of sync up with people joining. So we first make sure that it's grabbing, which is that variable that we had done stuff with before. And if it's grabbing for that local player, then they will set the state to 5. Because this technically is only working for the person holding the fetchable object. However, because they're the owner, they can always be able to just set the current state. And we want to make sure it's on ownership transfer to make sure it all happens once ownership is secure. All right, now we need to go back to our controller and add another ownership transfer. And honestly, this almost entirely is just for late join sync support. So first, we'll want to do that variable, which is, this is why we had set it to public, because when it was private, we weren't able to actually access it from here. And first, we make sure that if they're not grabbing, then it will set it to 0. So like, let's say someone leaves and they're not actually playing fetch, then hey, there we go, now it's there. And even if someone leaves and the person that leaves is playing fetch, when ownership is transferred, the person that is not playing fetch still doesn't have it shown as grabbing because they weren't the one holding the pickup, so then it still sets it to 0. So then no matter what, when the person controlling the AI leaves, it will reset to its wandering state. And right here, this is just the update rotation stuff for the on animator move that we had done before, and that just keeps it all up to date. Okay, and then lastly, we are going to do this wonderful thing I learned from Panda like yesterday, or actually no, it was like a few days ago, called flag discontinuity. This will make it so that we can, when the AI does specific things, we don't want it to do any lerping or any of that stuff, so then it just teleports to it. And then we just add these few things to the different areas, like this is in the update loop with the is being carried back. And then in the reset pickup, we can also have it so it flags discontinuity when it teleports back. There we go. And now it's synced. Also, I'm going to have a public world later with it all being in that world alongside the prefab. So if you want to play with it later, you can. All right, now the last thing we're going to talk about is the few limitations that I have noticed with the just different things we've been doing. This is like stuff in Unity, but we don't actually have access it into VRChat. And the biggest thing is agent types. I still want to see if I can get it working, but I haven't. And this allows different things such as radius, height, and stuff like that for different things. Like, so you have humanoid, for this example, we have humans, spiders, giants, and wisps. You want them to be able to have different heights and different settings for different parts of different nav meshes. And you can't, because that doesn't upload at all, and it's annoying. And the last thing, this is actually something I learned about while making this talk, is inside Unity's documentation, they have something called Nav Mesh Building Components. The best comparison I can make it to is standard assets. They made their own thing to make their nav meshes actually be a lot better and able to do a lot more with them than we have, but we can't use it in VRChat, and it's annoying. But with that, we can do super fancy things like generating nav meshes during runtime. We can have off-mesh links with like big 2D planes. It's cool, but we can't do it. There we go. That should be everything, probably. Hopefully. Got any questions?
Yes.
Woo. Yay! Nice.
Good job. I think there is my control orange.
All right.
Yeah. First question, if you don't mind, can you try and re-explain quickly what carving does, the carve option in the
Yes, hang on. I have notes for that. I just didn't read them. Okay, so actually, let me find the notes. Nav mesh obstacles. There it is. All right. So carving. And actually, I could probably that's like 60 slides back. Never mind. But okay, so carving in relation to nav mesh obstacles. So what carving is it allows a dynamic object that you're moving around to actually cut into the existing nav mesh. So think of how you have a static, like let's say you have a big flat plane and you have a static cube in the center and you see it around that. With an obstacle set to carving, you can make that cube dynamic and it will still cut out the nav mesh. So like let's say you have this like you have this long hallway, and in the middle of the hallway you have it's like all built like boarded up or something. And you want stuff to eventually go through it. So a good example is like Call of Duty zombie walls. Like when you're boarding up windows, you don't want them to go through it right there. So like each board would be an obstacle and it's set to carving. But as soon as it moves, it is no longer carving into that specific area, so it reverts back to its uncarved state.
I see.
Is that a good enough installation? I can go into it more if need be. Okay.
I guess I'm not sure what the difference between an obstacle that exists by default as an object that has the obstacle component and one that has carving.
So
A door.
when it doesn't have carving, it doesn't cut into it. So it's possible. So the nav mesh is technically still there. It's just it is directly around it. The big thing with this is that when there's a bunch of them, AIs will the path will still, like let's say you have two boxes right next to each other. There's a teeny little sliver in between them. It will detect that teeny little sliver if they're not carving, and it will try to go through there, and it will just get stuck. When it's carving, it just adds a big barrier around it that prevents it from having stuff like that. So it's really good for big cluttered environments.
Okay. Second question I have is that you mentioned off-mesh links, but I was wondering if the method you would use to get off-mesh links that tie into an animator, for example, let's say you wanted to have an AI agent that jumps in between off-mesh links, would you also use the same method as the guarding that basically has a collider trigger that ties into a parameter to make, have a jump animation in between off-mesh links?
I mean, the off-mesh links isn't tied to any specific state, so they would be their own thing. So you mean like if they were like going towards you and then they like jump onto you?
No. You had an example where you had only very like tiny squares of nav mesh, nav mesh onto big spots, I guess, and the nav mesh agent would have to jump onto those spaces.
Mm-hmm.
How would you make the nav mesh agent understand that there's a jump and make that nav mesh agent trigger a jump animation in the animation?
Okay, so that's the part of the feeding into the animator. We can, in this, actually, I lined up really well. In this, we can actually detect we can do two things. In this, I only showed you the off-mesh link. You can detect both the off-mesh link and the distance that it's on the nav mesh link. And using that, you can do different things like setting, like, hey, it's moving around, or hey, it's at this height, let's make it go to a certain position based on where it is. Because by default, nav mesh links are just a starting point, and point will go directly between them. So with animations, you actually will have to, based on its position on that, change the height in the animation itself. That's super complicated, so I didn't go through it in this. And honestly, I haven't messed around with it enough to figure out exactly how to do it, but yeah.
Fair enough, thank you.
Okay. I have a question. I have actually two questions. One with the you say waypoints. As far as like guards controls going between waypoints, would you mostly use like empty game objects and their transforms for a waypoint, or is there something more optimal? In an AI, the destination is just a vector 3. So if you want to have a patrol route going around like in a circle, then you could just have in the actual check itself be like, hey, if it's less than this distance from its destination, because there's a variable called remaining distance, you can just have it automatically cycle through to the next one. And if you have the auto stopping thing turned off, auto braking, it'll just immediately go on through it to the next one. Okay, and this next
question. I know this talk went over just one AI and one doggo, but let's say you have, let's say, even like 4 AIs or even 5, and all there's events that happens when they meet up. They detect that. Would you set like the instance owner as owner, like the master as owner? Is that like something you would have to set up before?
You can, if it depends on if for when they're synced, if they're owned by different players. Usually you do kind of want to keep them as the same object, as the same owner, just to make sure everything's working. They do have built-in collision avoidance that would work for everyone synced, but for the most part, it would be good to have it set to owner. Or are you talking local?
Yeah, I'm talking about like all the they're synced. But let's say you have some villagers, and occasionally when 2 villagers meet up, they'll stop and mingle and talk a bit, or maybe interact a bit before they break off. That would be synced by the master, right?
It could be synced by the master or any specific person. As long as both AIs are owned by the same person, you can do everything locally. But if they're handled, and it is technically possible to have them be different owners, but that would just be overcomplicating it for yourself, and it really wouldn't be a need to, when you could just do a quick ownership swap.
Okay, thanks.
Hey, Centauri, thanks for the talk, Professor. I have a question about, let's say we have I have enemies who can shoot at me, but the enemies are in a different area. Like, I want the enemies to get into position to shoot me. In the context of VRChat, do we have facilities to do this using this?
I mean, are you talking things like barricades that they would stand behind, something like that?
Yeah, and not necessarily try to reach me. Like, get me the best position you can to shoot at me, for instance.
There's a few different ways to do that. By that point, there would be a good way to choose priority points would be to differentiate them using something like a special area mask specifically for them. But for something like that, you would have to dynamically raycast towards the player or choose a specific position. It's possible. It's just something that would be complicated stuff, because rather than chasing the player, you would have to detect it's wanting to target a player, and then you could find like the closest using the area mask. You could find the closest point to them that is in that mask and have it target that instead, using the calculate position thing that I showed before. There's lots of different ways to do it. But it's definitely something that would be extremely complicated to do.
All right, thank you.
Okay, is that it? Okay, let me boost my weights. Okay, so yeah, I guess that's it. And thanks, Centauri, for a great talk. And I think it will be the most useful as a tutorial for people to just watch later as well on the YouTube when they need to implement it. So yeah, it would be great.
Yeah, let's make sure to do it with audio so they can hear my fixes for the little things that I missed.
For sure.
I have a full prefab for it that has the fixes, so it'll be fine.
Awesome.